And for now, we actually invite you to present also your next presentation, also by Pak Dena in his other team, titled Experimental Testbed for Solar PV Battery Hybrid System. Okay. While Pak Dena is preparing, I want to remind everyone to fill out your attendance list in the link you can find in the chat room, and also please remember that by filling out the survey provided by the committee, you are going to be eligible to be included in the door prize. But make sure that you fill it out at the latest at 1 p.m. So please don't forget to fill the attendance list as well as the survey. So you have two links. Okay, Pak Dena is ready. The presentation is already visible, Pak. Please, you can start your presentation.
Thank you, Budia, for this second opportunity. I would like to present to you the work on the experimental testbed for the solar PV battery hybrid system. The team for this is myself, Dena Hendriana, with Pak Erikson, Ferry Sinaga from MT, and Pak Arko Djajadi. So the motivation is also in Indonesia, even more solar energy potential in this area, around 208 gigawatts. So that's even higher compared to the wind. And then solar radiation is available during the daytime, while most of the household need to the electricity to be around evening to nighttime. So I'm thinking that the utilization of this research is for the household application of the solar system. The smart solar PV battery hybrid system for the application of residential house is needed to harvest solar energy during the daytime, store the energy in the battery system, and distribute the electric energy mainly during the nighttime. Testbed for this smart solar PV battery hybrid system is built to verify the concept and to identify the practical problems in the system. So let me bring to you on existing product. There are plenty of product already. However, as you can see, their products still expensive in the eyes of Indonesian, I guess. And also the capacity is also a lot of them large, and also something that we want to take some flexibility. So the benefit of our development is basically we try to have it less expensive, more flexible in terms of setting, meaning setting is like when the time, what is the amount of the power generated, etc. That's how we have the flexibility for that. And also the more source of the energy options. For instance, if in some area we have some wind available, then we can have this smart hybrid to include the wind, and even to include some micro hydro also is possible. So any electric generation can be included with our smart system, basically. However, in this research, we are not thinking to dig more on the solar PV, but we are going to utilize that. So we are just looking into the integration. Yeah, the solar PV is already mature, and we see the optimal price is already there, and the price for the solar panel now is very affordable. So the methodology that we do definitely is to look for the literature review and market review to find the good system, the hybrid system, as the initial design. To calculate this is the important part, to calculate and estimate the available solar energy in the site that you are trying to analyze. That's also very important because we cannot. You have to know how much energy there available. Okay, then after that, knowing what is the energy there, then we start to design the smart solar PV, and we want to use this inexpensive polycrystalline solar panel and also the battery, because we want to use that during the nighttime. We use this automotive battery and also affordable inverter and charger in the market. Okay, so you can see we are getting some product with the basic functionality, and then we put the smart controller that we are developing based on the Arduino Mega microprocessor. So the target of the application is the household, mainly used during the nighttime. The first step is to estimate how much is the energy. You have a software available that you can use, that you can calculate in anywhere in Indonesia with this software. It's a free. It's based on the irradiation calculation with the weather data. This website is very useful for that estimation. In my place here on my site, that on the test site here, based on 1 kilowatt installation, we expect to have around 1,200 kilowatt hour. So daily estimated is around 3.3 kilowatt per day. Okay, so as I mentioned, that this is based on the data, NASA data, weather data. Okay, so the way we have it for the test, we would like to investigate several setup for the battery. I have this 4 group of the battery that we look for. So then the configuration that we have is that 1,000 watt peak of the solar panel will goes to the charger, and the charger goes charging the battery group, and the battery group is of the 3 large with the I even tried something different also. I tried the wet and the wet and also the dry free maintenance type of the battery. Then during the nighttime, I also have the inverter. The inverter is around 600 watt. So my setup, we have a flexibility of the setup here, that during the nighttime from 6 until 6 in the morning, if it can, then it will be on when the battery is larger than certain voltage. In my test is 3.31 watt, 31 volt. And I want to make it maximum, so I put that maximum 2 units running simultaneously. However, it turns out from the first experience that the battery turns out to be less capacity. Then I need to utilize the energy during the daytime also. So I turn on the inverter when the voltage is kind of high, which is 42 voltage. Okay, and also stop still in the high, which is 37.5 volt. So you can see the flexibility of the on and off the inverter can be done with this smart system here. This is the prototype that we talk about here, with the 4 set of the test group here. The battery is they are lead acid battery, such as available in the market. And then the smart system microcontroller is on the right lower on the box there that I put to control the system. Based on the test result, something quick here, I measure the AC output to the installation of the house. For the 9 days, I have 64.2 kilowatt hour. While if I measure that from the DC side, I'm getting a total of 83 kilowatt hour for same day, which is 9 days. So based on that information, then I can estimate what is the efficiency, which is 64.3 divided by 83, which is around 77% of the inverter loss, converting from the DC to AC, which is interesting because the spec is saying 86%. So that's something also about inverter. And then the hybrid system, this is the interesting part. For the 3 and 4, they are more productive than 1 and 2. with the daily 2.9. However, the 1 and 2 looks to be only small, 1.7 kilowatt per hour, while from the calculation it's supposed to be 3.3. So the battery 3 and 4 group, they are very close to what is expected. However, there's something that we need to investigate. The 1 and 2 that's not producing very complete. This is the result on 1 day test to show how the voltage. I'm getting only the voltage. I couldn't make the system running, measuring the current. So I have to rely on the voltage. What you can see that the voltage, the green and the blue, the green is number 1, the blue number 2 is starting at 18. However, there's something stopping them around 1812. That's something that I have to investigate why. That it turns out that based on the spec, the inverter running when the voltage of the PLN is higher than 190. It turns out in my side of the test, the voltage can drop lower than 180. So then the inverter has to stop several times. And in this day here, you can see that the run of the battery go all the way to around 2240, so which is kind of long, but not long enough to really utilize 3.6 kilowatt hour with the 600 watt. That's supposed to be 6 hour running straight, which is not what we have. Another thing that we look,
because the time is running out, you have 1 minute left.
Okay,
thank you.
I'll do it quickly. So another thing that I look into also the wire condition, that the hardness. So it is necessary for you to pay attention on the wiring. It needs to be thick enough. Conclusion is that we already have developed the test bed for this one. What we learned from this test is that daily the kilowatt hour is not achieved, and then inverter efficiency is less than the specification, and then also the battery is not working really well also, not the capacity that they specify, and also the things important is also inverter voltage is not really well with our situation. So the challenge, as I mentioned here, about the inverter, that with the voltage and also the efficiency, and then also we need to pay attention on the wiring, that need to be good enough, otherwise some hazard issue, the safety issue. And also if you use lithium ion, be careful, because if you overcharge, it can explode. And also the last one here is that we need to find a good DC current. What next step here is that we need to look a better battery that with a good capacity, with the inexpensive one, with a longer life. And second, to get a good inverter that can run with 190, lower than 190 volt. Okay, and with the higher efficiency of the DC to AC. That's all. Thank you very much.
Thank you, Pak Dena, for your second presentation. Now, I'm going to directly read the question coming from Mr. Niki Prastomo. Excuse me, from Mr. Satya Damba. First, Pak Dena, if comparing to the existing service from PLN, how much the power that the 1 kilowatt power installation or 3.3 kilowatt hour per day be suitable for household supply?
So the 1 kilowatt can produce daily around 3.3 kilowatt hour, depending on the usage of the household. If the household is kind of not really utilizing a lot of energy, so really it depends on the lifestyle of the house, basically. So, and then typical 1 kilowatt hour in Indonesia area is around 3 kilowatt hour, typical 1 kilowatt solar panel. Yeah. So then if your house needing around 10 kilowatt hour per day, then you basically need 3,000, etc. So really depends on the lifestyle. However, you need to think about the battery right now. The battery technology for supporting this solar panel is not really working well or too expensive. If you go with a very expensive one, definitely you can have a nice product. However, too expensive, it means that the investment is high and the return will be kind of not really interesting. Yeah. So really, so if we have a good battery, if right now the technology is ready when there is no battery, it means that no hybrid. It's just basically having the solar panel with the inverter, and then the energy of the electricity from the solar panel is directly used without any storage. Then with that situation, the investment can return nicely around 5 years to 8 years. However, with the battery, it's still not very attractive. I hope that answers the question.
Okay, thank you, Pak Dena. Second question is from Mr. Niki. Is there any possible imbalance of charge and discharge of the batteries used? Some batteries are more charged and drain more than others. Thank you.
Yes, in this project, that's the reason why I look into several kind of the type of the battery. That's why I have that in the several groups, and I try to evaluate how they are performing. So from my experience, the wet battery is more robust in terms of the free maintenance battery. Free maintenance battery is kind of similar to the wet. However, they use some kind of the valve to protect the evaporation. However, the robustness for the wet battery is more robust. Now, in terms of the balancing, my suggestion is that you should not use different type of the battery in one bank of the group, because then, as you mentioned, the imbalance of the battery will reduce the optimal energy being absorbed by the battery. The battery will be driven by the weakest component. So definitely mixing battery is not very recommended for that because of the balancing. I hope that answered the question.
Thank you, Pak Dena. The next is from Ibu Evita, probably more of a comment rather than a question. Very interesting, Pak Dena. One of your problem is with the battery. So I would like to suggest, because we have Prof. Agus here, maybe we can work together with UNS. That's a very good idea, and I hope this can also continue to further research together.
Definitely, yes, definitely. If I also make a comment that I would like to work together with Pak Agus, maybe with different type of the battery also. Pak Agus looks to be specializing on the lithium. Then we can try that with the lithium, but also the other type of the battery can be also interesting. I'm thinking to have cheaper battery that I look into the literature with the aluminum, with the type of the battery. So yes, I would like to do that, definitely, Bu Evita. Thank you very much.
Wonderful, Pak. And one last short question before we end this session. Practical question from Mr. Aloysius Sigit: how the system will be integrated with PLN? On or off grid?
Yes, actually, that's the interesting question. Yes, which I did not pay attention to the detail there. Yes, the development of our test bed here is on grid. So it's an on grid type of the inverter. What is the benefit of the on grid type of inverter here is that we can supply energy to the household without modification of the electric installation. So the interesting part of this inverter is basically the energy coming from the inverter will be absorbed by the household quicker or before the PLN. What happens is that this inverter will provide slightly higher voltage than the PLN. So by having that higher voltage, then that guarantee that this energy, that source of energy coming from this inverter will be absorbed before the PLN. So what happens if the power being absorbed is less than the power being supplied by the inverter, the voltage will still up. However, when the voltage cannot hold that, then it will go down to the PLN. And then after that, the PLN will handle the voltage for the household. So that's how it works. Thank you very much for that question.
Okay, thank you very much for answering all of the questions, Pak Dena. Very interesting indeed. We have sensed a very big interest coming from the participants. And thank you all the participants for the participation and active cooperation in the session.